end.
Oh my.
It's okay.
But we were winning. We were.
We're working on next year's A, guys. All right, go ahead, Miss Rondeau. I'm going to let you take it away, and I'm going to pick up from wherever you want to stop.
Okay. Well, good morning, everyone.
Seuss is here. I'm sorry. I'm excited now.
Hey, Seuss is here because you have another one?
Yes.
Yeah, whatever. I think Mrs. Ballard has me by like 1. I could count, but I'm pretty sure she's winning by 1.
I'm just excited. We've got 24.
Yes. Good job, guys. Thanks for joining. We're going to continue in our Radians and such. But first, because we don't want to forget to do it.
Playing your jam. I'm shutting it off. It was handsome.
Oh, yes. Yes. Well, because I'm going to add in new music because we didn't record the Greek alphabet and there was a comment or something yesterday about that. So I guess I'm torturing everyone with the Greek alphabet once again. So
hold on, I'm trying to go to full screen here. Don't start yet. Change
okay,
layout, spotlight. Oh, if I turn this thing. Okay, there you go. You're on.
Okay, full screen. Here we go. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, upsilon, b, cube, c, omega. This is the Greek alphabet. There you go.
Yay!
Now it's recorded.
Oh, you got
I got some claps.
All right.
All right.
Change it back to kind of a side. Okay, go ahead.
I'm going to switch to presenting my screen here so that we can jump in. Okay, so this should be, are we seeing my screen?
Yes.
Fabulous. This should be where we left off yesterday. We didn't quite make it to example 3. I'm going to move, sorry, moving my picture there a little bit. All right, so this question, it says determine 2 coterminal angles in radian measured, so 1 positive and 1 negative. For this question, we talked about coterminal angles yesterday, so just a reminder of what that means. Coterminal means we start and stop at the same places in measuring our angles. So we're going to start with a little bit of review from yesterday. My part A is pi over 6, so I'm going to start by drawing pi over 6. So I start with 0, pi, and 2 pi. That's my basis for building any of my angles. And then I'm going to do pi over 6, and it already tells me I'm dividing pi into 6 pieces, and I'm going to remind us that there's a 1 in front, so we want the first piece of pi over 6. But I'm going to take this and go ahead and divide it, and I'm going to try and do the whole circle at once today, trying to improve my skill here since I don't usually do the whole circle at once. Ooh, look at that, not too bad. So I'm dividing pi into 6 pieces, something like that. Don't mind the fact that they're not perfect. Okay, so I should have 6 pieces in the top and 6 pieces in the bottom. And I want the first piece, so my angle is right here. This is pi over 6. That represents my first angle. I'm going to highlight for us our initial. Oh, I should have done it in purple, Miss Ballard. Oh, well. All right, so my initial side is the x-axis.
Oh, Merry Christmas.
I love Christmas. We're only at, oh, shoot. I don't know how many days there are until Christmas. This is a crime. I'm sorry. This is very important to me that I know how many days there are till Christmas. All of my students know that's very important. 232 days till Christmas.
Okay.
Okay. Back to the problem. So that's my start side. It's green. And then I'm going to, since I made my picture in red, I'm going to go to purple for my stop. So I start at green and I'm going to stop at purple. There's my terminal side. All right, so I need a positive and a negative coterminal angle. So I'm going to do these in apparently blue. All right, so the only rule is I start at green and I stop at purple. And I want a positive and a negative. I'll do the positive first. So I'm going to start at green and I'm going to work my way around. I can't stop yet because that's exactly the same angle, pi over 6. So I just keep going around and around and around and around and around and around, all the way around till here, and I'm going to stop. Now, if I was being a little bit more smarter, quicker, faster, I would have been counting as I went. But basically, I'm going to count how many pi over 6 sections I went through to get to that stopping point. So here goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that would be 13 pi over 6. So there is one coterminal angle. We started and stopped in the same location. So that's our positive. Then to do the negative, sorry, that was so close to the other one. All right, then to do the negative, I need another color. Maybe I'll do black. Yeah, let's do black. Okay, so negative, I'm going to start at green again, and I'm going to work my way backwards. And this time I am going to count as I go. So here goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I have to stop at purple. So that gives me, and I'm going to just sneak in the 11 pi over 6, and that is negative because I went in the negative direction. So those are 3 coterminal angles. Pi over 6 is coterminal to 13 pi over 6 and negative pi over 6. And that is just how you can create coterminal angles using the picture. And so that's where I'm going to stop and hand it back to Miss Ballard to go through the next several. I didn't actually talk to you, Mrs. Ballard, about this, but I was assuming based on previous notes that you were going to do it by arithmetic, the adding and subtracting. Is that correct?
Yes, I'll do the adding and subtracting. I have one question for you, though, because I like your picture there, and I'm not going to use the picture.
Okay.
Are there any other coterminal angles other than those 2 that are also positive and negative?
Ooh, that is a good question. Why don't we have the students put that in the chat? Just a yes or no. Are there any other possible coterminal angles besides the ones that I created?
What do you guys think? Put it in the chat. Yes or no?
Then I get a coffee break. That's really why we have them answer in the chat, just so I can drink my coffee.
I have an I don't know.
I don't know is a fair answer.
Maybe.
Maybe.
Yes with a question mark. We're getting closer.
Okay, so
Yes,
let me, while they're trying to answer, I'm going to come back with another color and see if I can create another angle. Remember, the only rule is we start at green and we're going to stop at purple. So if I start, and I'm going to make this picture really, really messy. So here goes. I'm going to start at green and I'm going to stop at purple.
Woo, that looks awesome.
Was it possible for me to start at green and end at purple and create a different angle than the ones I had already created? Yes. You could go around.
I saw you get like 4 different ones as you were doing that.
Yeah, every time I passed by it and I didn't stop, I could have, and that would have been more. And again, we can also do that in the negative direction. So I could have just as easily started at green and gone the other way, all the way around the circle. So there you go. That's kind of,
we're up to 27 now.
27?
27 today.
What's 27?
That's how many kids we have.
Oh, 27. Oh, I'm sorry. I missed the first part about what it was. Yay. Okay. So you guys can see that there's lots of possible answers. You basically can create as many. It's how many times are you going to go around the circle is basically what you're doing. Because you can see on my orange one, I went around the circle multiple times. And as Mrs. Ballard said, I could have stopped at any point along the way at that purple, but I just kept going around the circle. So it's basically how many circles am I adding to my angle, or how many circles am I subtracting or going backwards to create my negative? Ooh, let's really quickly, let me illustrate that. Let's see, I'm running out of colors, different variety of colors here. Let's go dark blue. Okay,
yep.
Here would be a negative one just to make it nice and messy. Start at 0. 1, 2.
Oh, there was 1, 2, 3.
Just keep going. All right, and I'm going to stop there. So again, you can see going all the way around, I've made lots of coterminal angles. Anyways, that's nice and messy now. So with that, Mrs. Ballard, it is all yours.
Okay, I'm going to go ahead and present my screen. Mrs. Rondo's right. I'm going to take a slightly different approach, but it's good for you guys to see more than one approach to this. Okay, and my examples might be labeled a little differently, but they're all the same numbers. So let me fix this here because I'm using something a little bit different. We were on this right here. Okay. So it looks a little bit more just like your note page. You're going to see my ceiling and hopefully not my nose. So Miss Rondeau just did the pi over 6. And when she did that pi over 6, you'll notice that she did one full revolution around. And anytime we do one full revolution around, that's 2 pi. Okay. So I use that as with an algebraic approach. So I know that anytime I'm going to, well, and I have to kind of start with what's there. I need to either add or subtract. So I'm going to add 2 pi or I'm going to subtract 2 pi to get coterminal angles. I also have to be cognizant of the fact that we have different denominators. So I might have to work with that denominator and come up with some common denominators. So I have to figure out 2 of them. This one here, actually, I'm going to work in over 4 world first. So in over 4 world, I know that, oops, I lost my pen. That 2 pi in over 4 world would be 8 pi over 4. So all I did to get that was an equivalent fraction. Okay. So when I'm working in over 4 world, I know 2 pi is 8 pi over 4. So just like in the other one, I might need to add to get coterminal. I might need to subtract to get coterminal, and I just need one positive and one negative. So what you're going to do each time might vary depending upon where you start. I'm going to, in this one, I'm going to start with subtracting 8 pi over 4 and seeing what I end up with. So 9 pi minus 8 pi happens to be positive pi over 4. Well, I just got a positive angle by subtracting. So I know I haven't gotten to a negative one yet. So I'm going to go again. So I know that this is one of my answers. I'm going to go again and I'm going to subtract 8 pi over 4, which is like 2 pi. And I know that I get 7 pi over 4. So now I just got a positive and a negative coterminal angle. Those are not the only ones. I could have chosen to, instead of subtracting here, I could have added 8 pi over 4, which would have gotten me 17 pi over 4, and that's another positive coterminal angle. The hard part, the downside is I would have had to do this anyways to get to my negative one. I'd have to subtract more than one time. So you can kind of pick if you like the analytic method that I showed or the picture method that Mrs. Rondeau showed.
Or sometimes both.
Or sometimes both. Yeah, it does. Sometimes one is better than the other. Sometimes drawing the picture might get annoying, and you might just want to add, subtract 2 pi if you can remember to do that. And sometimes knowing that, understanding that revolution is 2 pi is actually really an important thing. I'm going to go ahead and do this next one here. So at this time I have negative 5 pi over 3. So first I want to figure out in over 3 world, what is 2 pi equivalent to? So I would take and I would I know I got to multiply the denominator by 3. So I multiply the numerator by 3. So I know that 2 pi is equivalent to 6 pi over 3. So I'm going to just start by adding and see what happens. I know I got to get to a positive one and a negative one. So I'm going to add to that and see what happens with it. So 5 pi over 3 plus 6 pi over 3 gets me pi over 3. Okay, so I've got a positive one, I need a negative one. And normally you guys, I don't know if you guys have noticed, I never box my answers. I'm boxing so you can see it, and that's the only reason. I'll tell you next year why I don't box my answers. All right, so I'm gonna try subtracting my 2 pi, which again in over 3 world is 6 pi over 3, or negative 11 pi over 3 would be my negative coterminal angle. Something that we might want to just put in the left-hand column, okay? Because you work in a couple of different worlds here. Let's put our equivalent fraction ratios out in that left-hand column for 2 pi. So we know 2 pi is equal to, we just said in over 4 world, it's the same as 8 pi over 4. In over 3 world, we said that that is 6 pi over 3. In over 6 world, and these are the ones we use the most. In over 6 world, I would have to multiply by 6, so I would get 12 pi over 6. I'm going to do over 2. That one doesn't come up as much, but just so you got it. In over 2 world, it would be 4 pi over 2.
And just let me throw in those equivalents. All of those should be on the circles that we built yesterday. Those, yeah. I like it all in one spot, but just you also have it in the circles.
Yeah. So that way if you're doing this conversion, you just have to understand what 2 pi is equivalent to. And sometimes the fraction part's the hardest part. Most of us can remember add 2 pi, subtract 2 pi. All right. Since I don't have my PowerPoint version going, I'm going to write this out. So I'm sorry you have to read my handwriting. Complement and supplement, though, you should know these from elementary school. We're going to put a little bit of a trig twist on it. Okay. So complement is two angles whose sum is either 90 degrees, that's the one you should know, or pi over 2 is what we're going to add to it. And then that was the complement. I think I may have said supplement. Supplement is two angles whose sum is 180 degrees, or in our case, pi. And one thing we have to note is the angles have to be positive in order for this to work. Okay. All right, so we are supposed to find the complement and supplement of each angle. So I am going to, so complement again is the pi over 2. I'm looking at my notes. I didn't look too far ahead in advance. And supplement is they have to add up to pi. So really what I'm going to do is I'm going to subtract from pi or pi over 2 and find the absolute value of that because they have to turn out to be positive. So for my complementary angles, and we're going to do this in degrees in a few minutes here, I would do pi over 2 minus 2 pi over 5. And those are absolute value bars. Are you going to be dry enough for a joke in a few minutes? They've been doing PE in the pool this morning.
I was like, dry? What's going on?
All right. So obviously I can't add a denominator of 2 and a denominator of 5 together. I have to make a common denominator. So I'm going to make a common denominator of 10, which means I need to multiply the pi by 5 because 2 times 5 is 10. And I need to multiply the 2 pi by 2. So I get 4 pi. Andy, I need you to be quiet. I'm teaching a live class. Okay. And then 5 pi minus 4 pi is pi over 10 would be the complement. I still need to find the supplement of that angle. And the supplement of that angle would be subtracting from pi. So, Andy, go upstairs and change. All right. It's great being a parent and teaching at the same time. All right. The calculus has gotten to hear me to get after him a little bit more. It's been a lot of fun. All right. Craigworthy, apparently, because he figured out.
And recorded for all eternity.
He figured out how to hack into my Google Meet class. He's in 2nd grade. So I'm going to cheat a little bit on this one because of space. I know that my common denominator has to be 5, so I'm going to put a 5 on the top and a 5 on the bottom. So 5.
Mrs. Ballard's cheating.
I know, it's rough. We'll get over it. All right, so 5 pi minus 2 pi is 3 pi over 5. I'm going to do the next one just a tad bit faster. Let's see. Oh, we'll go pink. All right. So my complement on this one here. I know I have to go pi over 2 minus 4 pi over 5. I know I need to be in over 10 world, right? Because in order to make a common denominator. So I need to multiply the 2 by 5, so I get 5 pi. And I need to multiply the 4 by 2, so I get 8 pi. And do you notice how this time it's going to be a negative number, but we said we always had to be positive? That's why we're using the absolute values. Ignore the little 64 that's there. That's the page number, apparently, that I had it on. Because I grabbed last year's just 2nd semester notebook. 3 pi over absolute value, negative 3 pi over 10 would be 3 pi over 10 would be our complement. All right, our supplement is going to be pi minus 4 pi over 5. And again, I'm going to cheat. I'm just going to make my common denominator 5 on the top, 5 on the bottom. 5 pi minus 4 pi is pi, so we're just going to drop the absolute value bars. It would be pi over 5. Okay. So, do we have any comments, concerns in the chat there, Miss Rondo?
The only one was a question about if there was a limit as to how many times you could go around the circle for the coterminal angles, and I answered it in the chat, but there is no limit.
No, there is no limit. We can keep doing that forever. It's not recommended, but if you're bored, you've been quarantined long enough and you need something to do, you can go around that circle as many times as you want. All right. A degree is another way to measure angles. You guys are much more familiar with this way. We kind of started backwards. We started with the radians because that's really where we have to end up eventually in trig. But this is kind of a reminder. A degree is another way to measure angles. 1 degree is equal to 1/360th of a circle. I should have really written it out like this. 1 degree equals 1/360. I don't like sloshy fractions. So that's like my biggest pet peeve is sloshy fractions. All right, let's see.
I'm with you. Yuck.
Let's see. Okay. So the next thing I'm going to do too is I got to determine which quadrant each one of these angles lies in. So I like to kind of just sketch my little picture. I know that this is 0 degrees. I'm going back to degrees. This is 90, 180, 270, and of course this is also 360 degrees when I make a complete revolution around the circle. This should be a little bit more familiar to you guys. 274, well, that's pretty easy to tell. It should be right here, right? 274 degrees. So we know that, remember, as from yesterday, this is quadrant 1, 2, 3, 4. So I know that that has to be in quadrant 4. And we use the Roman numerals when we are labeling quadrants, not just an integer number. 153 shouldn't be bad now that we've got that drawn. 153 looks like it lands somewhere here in quadrant 2, and doesn't matter that there's a little decimal point after it. So we know that that's definitely a quadrant 2 answer. The next thing is I'm supposed to sketch the angle in standard position. So let me draw, I'm going to draw a couple of XY axes on here for these guys. I'm going to do them separately. I believe the ones we are assigning are in WebAssign are multiple choice. So you're just going to have to kind of pick which one lands in the right spot. We always have that, and I'm going to do it both on the same one, so you say use the same color. We always have an initial side. You want to draw that first. And then when we're going in the positive direction, so positive is counterclockwise. Okay. Oh, it can't be Christmassy. All right, 120. We know, again, this is 90, this is 180, 120's got to be between them. You're going to estimate. And then what I always do is I draw a little arc in there and I label it with whatever my angle measure is. So that way you've told whoever's grading you that, hey, I understand that that's the angle that's 120, because there is technically a second angle over here on this other side that goes in the negative direction. So you want to tell us which angle you are interpreting it as.
Mrs. Ballard, I'm so sorry to interrupt. I have to talk with my kids for a minute, so I'll let you know when I'm back.
Your own children?
Yes.
Sounds good. I'll just keep on going.
Keep going. I'll let you know when I'm back.
Okay, sounds good. All right, so you guys, if you need something, I'm not looking at the chat and I don't have a second screen going, so you guys have to get off your microphones and tell me, okay? If I miss something or something messes up. All right, let's do something with sparkly colors. So 220, let me label this again. It's negative 220, so I'm going to label this graph a little bit backwards. I'm going to say that this is negative 90, because it's 90, but it's just in the opposite direction. Negative 180 and negative 270. If I do that, I'm going to probably pick it up really easy where my negative 220 is. So I know that negative 220 would land between negative 180 and negative 270. So it should land in there. And then I would draw my arc going this way as negative 220 degrees. Okay. All right, we've gotten there. We need two coterminal angles. Okay, so we are going to determine, oops, there we go. Two coterminal angles in degrees and measure, in degree measure, one positive and one negative. Well, hopefully you caught on. I'm going to put this in the left-hand column. That 2 pi is what we did on the last time. We either added or subtracted 2 pi. Well, 2 pi is the same as 360 degrees. In a few minutes, we're going to learn how to convert that, okay? But we're either going to add or subtract 360 degrees. So that shouldn't be too bad. And again, you kind of have to play with the number. You could do this and count the angles just like Mrs. Rondeau was doing, or we could just do it analytically. I'm going to choose to do it the analytic or the algebraic way. So I am going to start with adding 360 degrees and see if I get a positive. If I don't get if I get a positive, I know I got to go the other way to get negative. If I get a negative, I know that I got to go. I kind of got to go backwards to get positive. So I kind of got to play with the numbers that are there. So I'm going to do 45 plus 360, and of course I don't have an answer key in front of me, so I'm going to use my calculator. So just in case I mess that up. All right, so I ended up with 405 degrees. If I'm getting it wrong, yell at me, okay?
You're good, Mrs. Ballard. I'm back too,
Good.
by the way.
I didn't do the, I don't have my, I for some reason didn't pull up a screen with my answer key on it. All right, and then we're going to do 45 minus 360 degrees. And you don't really have to put the degree symbol on there until the very end. That's fine. All right, so 45 minus 360, I'm getting negative 315 degrees. And good news, I have one positive and one negative. Andy, I need a joke in like 40 seconds. No, 2 minutes. Okay? Okay. All right. He's drawing now in case anyone was worried about that. Okay.
Well, good.
All right, then 420. I could go either way with this. If I wanted to, I could start by adding 360 degrees. So when I do 420 plus 360, I get 780. All right, now I'm going to try going the other way. 420 minus 360. And I end up with 60 degrees. So I didn't get to a negative one yet. So I need to keep going another round here. So 60 minus 360, I should get negative 300 degrees. Now I have at least one coterminal positive and one negative. I know when I was looking at the answers in WebAssign, they have a couple of possibilities in there. You might have to play with it a little bit to get to what they said the answer was, but just know you might have an answer that's right, but they might not count as right because of the way they put their answers in. All right, one more, 135. I know for sure to go, I got to add to get at least one round to go positive. So 135 plus 360 in the sparkly colors, 3 is going to be 225 degrees and it's positive. So I got my positive one. To get negative, I'm probably going to need to subtract that. So I get negative 400, that's a negative 495 degrees. Okay, I've got one more that I'm going to do with you guys, and then we're going to skip some stuff.
Yay!
Yay! All right, we need to find the complement and the supplement. We're only doing one of these because I know you've been doing complement and supplement since elementary school. So we shouldn't really need to cover this, but we're going to just in case. 90 degrees for I have to add to 90 and then add to 180 for the supplement. So I know I have, so basically for my complement, I'm going to do 90 minus 85. And again, they really should be positive. So that's going to be 5 degrees. And then for my supplement, I've got 180 minus 85. Double checking, 95 degrees. All right, do we have any questions, comments, concerns? I know I kind of went quick. All right, so the good news, you guys. Oh, Andy, joke time. We're going to get rid of degrees, minutes, seconds. We're not going to mess with it this year. So I tried to avoid the problems that had that in it for those of you that are that attempt the homework. All right, here he is. Oh, hey. Say hi, Andy. Okay, hey. What's the joke?
Why did the boy eat his homework?
Why did the boy eat his homework?
Yeah.
I don't know why.
Because his teacher said it was a piece of cake.
Okay.
Well, I wish I had some cake right now.
Yeah, me too.
All right, Ms. Rondo, take it away. I'm super looking forward to understanding how to convert from degrees to radians and radians to degrees. I can't wait to learn about that.
Can't wait.
I can't wait.
All right. So on the top of, it should be, I believe, page 254, you have a box that has this. You're adding in the conversion here. This is pi. The RAD stands for radians. We don't normally write the RAD for radians because it's not really a unit. I mean, it's a unit, but it's not a unit. It's really a pure number because it's about revolutions. So we don't normally write it, but this is just to be clear that the pi represents the measurement in radians and then 180 degrees. So go ahead and jot those down. So a quick rule of thumb here when you're trying to figure out what to multiply by, if you look at these two fractions, they're basically the same fraction, just flipped. It's the reciprocal. Whatever you want your answer to be is going to go on the top. So that's kind of a quick, you want whatever unit you want your answer in, that's what goes on the top. And then pi and 180, the reason that this actually works is because pi radians is equal to 180 degrees. So this is just unit conversion. Pi over 180 is actually, the fraction itself equals 1 because those are the same value. Actually, they just have different units. Okay, so here we go. We're going to rewrite the angles in radians. So I have 135 degrees. It says don't use a calculator, but the point is not to just grab a calculator and multiply by pi over 180. We're going to show it algebraically or show our math here. So I am going to multiply by pi over 180 because I want it in radians. And I'm going to put 135 over 1. Then part of the deal here is the way this works is my degrees actually cancel with degrees in the denominator. So that's part of why the setup matters. And then the 135 and 180, if you are not super familiar with those numbers, because I don't often try to simplify 135 and 180, you can actually use a calculator to help you out, even though the directions say not to. Currently, I have 135 pi over 180. That's just multiplying straight across, but I can reduce this by dividing the top and bottom. I just picked something I knew for sure. I knew they're both divisible by 5, so that when I do that, I get 27 pi over 36. And then from there, those are much easier numbers to work with. Now I could pick something a little more confidently. Okay, I know these are both divisible by 9, and I believe that's the largest number that goes into both of them. So I get 3 pi over 4. And then there's my answer in radians. We're going to keep scooting through unless there's...
Brenda, one quick thing. I just want to mention that we call that leaving that in terms of pi.
Yes.
And that's why it says do not use a calculator, because we will not see a decimal point answer on this. That's why we're discouraging the use of the calculator, because we don't want you to multiply it by pi.
Yes, good clarification. I boxed it so you guys can see. It says a multiple of pi. What that means is pi needs to be a part of our answer, like Mrs. Ballard was saying. So the do not use a calculator is not that you can't use a calculator, it's that we don't want it to be a decimal approximation.
Yep.
That's
right.
not, oh, go ahead.
Keep rolling. I'm good.
Okay. Yeah. All right, next one. So same basic idea. We're going to multiply by pi over 180. And again, I'm going to put 540 over 1. I can multiply straight across. If you're good with cross canceling, feel free to cross cancel. That's not a problem. And again, I want to point out those degrees are going to cancel out. 540 over 180. The zeros mean that I could divide both of them by 10, but I'm going to go a step further and actually go 54 and 18, I know are both divisible by 9. So I'm actually going to divide by 90. But again, you could be using a calculator to simplify this part of it. So when I do that, I get 6 pi over 2, which means I didn't pick the biggest thing I could have picked, and that's okay. 6 divided by 2 then turns into 3 pi. All right, so on to the next one. And if you guys have questions, shout them out or put them in the chat. Slow me down, Mrs. Ballard, if I go too fast.
Mrs. Rondo, we can stop at 18. You don't need to do 19 and 20.
Okay, gotcha, no problem.
Just so you know, you're doing really good on time right now. We still have 25
lots of time.
You're doing. You don't have to go at rapid pace.
But I like going fast. Oh no, I want to rush. No, actually, sometimes I'd have to slow myself down. I get so excited. It's so exciting.
I know.
Okay. So once again, I'm going to put this over 1. And again, multiply straight across or cross cancel. Since the other two I showed going straight across, this one I'm going to cross cancel. So again, I see that they both have a 0, which means they're both divisible by 10. But I'm going to go again a step further and maybe look at 27 and 18 are both divisible by 9. So I'm actually going to divide them both by 90. So I'm saying divide them both, but I'm dividing out 90. So cross canceling here. This becomes 2, and this becomes, I don't know why I wrote it so far down. Now that I'm slowing down, I'm like, oh, I just, went crazy. Okay, so this becomes 2. So 90 goes into 180 2 times. 90 goes into negative 270. That would be negative 3 times. When I fix all that up, it's a little bit messy. I have negative 3 pi over 2. So you can do it with cross canceling. If you were doing that, I probably normally would not write the divide by 90. I would just say, hey, they're both divisible by 90. But for your reference, I'll just make a note over here that that's what I did. I divided by 90. Any questions, concerns?
I think we're good.
All right. Now we're going to go the reverse. So we're going to rewrite each angle in degree measure. And again, the reason it says not to use a calculator is we want exact answers, but also you're going to notice there's something fabulous about going this way. When we want it in degrees, we're going to do 180 degrees over pi is what we multiply by. What is going to happen to those pi's?
Oh, I don't know. I think they might cancel.
I think you're right, Mrs. Ballard. Let's cancel them out. So those cancel and go away.
Doesn't that feel good?
It feels so good. And then I have, if I multiplied straight across, I have 180 degrees, negative, excuse me, don't forget the negative there. Woo. So negative and then divided by 2. That's a fairly simple problem, but again, grab a calculator if you want. That's negative 90 degrees. On to the next. Again, this one is a pure number radian, which again doesn't happen super often, but it does. I'm going to multiply because I want it in degrees. So 180 degrees divided by pi. This time there is no pi to cancel, so we're going to leave pi in our answer.
Miss Rondo, there's a typo in that one, I think.
Is there?
You were supposed to have a pi after the 2.
Oh, well, then I'll add it. Okay, it was really
it's
2
even
pi.
better now, though, isn't it?
I like it better. I much prefer to cancel the pi's. I'm just going to write that a little bit neater. There we go. Okay, so if there is a pi, then hooray, we get a cancel. And then do a quick 2 times 180 gives me 360 degrees. This one, though, if it started as 2 pi, at this point, we should know that that's equivalent to 360 because 2 pi is 1 whole circle and 1 whole circle. But you could do the conversion and see that it works as well. All right, lasty one. We have 9 pi over 2. Again, multiply by 180 degrees over pi. And the fabulous part is those pi's cancel. And then you can, of course, cross cancel if you would like, or just multiply straight across. I'll cross cancel again. 2 goes into 2 once and into 180 90 times. And that still is degrees, even though I kind of crossed it out. And 9 times 90 degrees would be 810 degrees. I think. Yes. Great.
Yes, you're good.
Fantastic. Then that's it. I think I'll turn this bad boy.
So one thing just to recap what we were doing, guys, if you have to turn it into radians, you need to put the pi into it, which I would say that means you have to have the pi on the top. That's going to put the pi into the expression. If you have to get it into degrees, you want to remove the pi, so you need the pi in the bottom. So it's 180 over pi. Okay, that's the only extra little comment that I would probably add in there. Anything else, Mrs. Rondo?
No, I think I'm good. Actually, for my students from yesterday's lesson, I did not post the video until this morning. Well, I didn't either. I didn't either. But I didn't set up the homework until last night from yesterday.
Me either. I didn't set it until this morning. We're equally as behind.
So today's assignment, I'm going to work on it in a few minutes. Hopefully I'll have it up this morning before noon. But I apologize for that. Also, another update for my students, and Miss Ballard can also maybe say something about this for hers, is I have not put in the logs, that second logs test that we did at the end of last week. It's like we're living the same world.
Apparently, we just share the same brain. That's okay. No, that's a good thing. It's not like we have anything else going at home, right?
No, of course not. I had to leave in the middle of the lesson to deal with my children, so I apologize for that, but it is the world that we're living in right now. They needed me. So, and they needed me, but they're a little bit older than Miss Ballard's kids, so they were nervous about interrupting, where it's just, Angie just comes in and gives you the problems.
Yeah.
Okay.
Yeah, at least there wasn't any screaming today. So,
Well, there was on my side, but we got it fixed.
so I do have a grand total for the day. So we have Mrs. Rondeau's class, 12 students. Mrs. Ballard's class, 14 students.
Whatever. Whatever.
Good job, my class. Keep coming. Come back tomorrow. We are super excited to see you. We hope you win. Angel, we got to keep it positive in the chat.
Positive.
Don't want your grade to go down to next year. Okay.
There we go.
All right. We will see you guys tomorrow at 10 a.m. We're looking forward to it. We're going to be doing some more trig. All right.
Right.
All right. We'll see you guys. Bye.
Bye, everyone. Thanks for coming.
Bye.
All right. Let's see.
Bye.
Oh, that's Andy. I was like, what is that?
Andy. We've got two. We'll get them tomorrow, Summer says. Stop recording.
Summer.